Okay, we are Francisco,
Eric, and Roger.
and we are team number 3.
What is the equivalent resistance of the arrangement in the figure? The current through each resistor when the circuit is connected to a 12 voltage battery. Explain the functioning coffee machine. First, we need to read and understand the problem. Then, we investigate the basic about circuits and Ohm's law. Third, apply the rule for all parallel resistors in the problem and apply the rule for all resistors in series. And finally, we obtain the current value with the comparison equation and in the investigation on functioning of the coffee machine.
This is a problem, and it is a circuit with different resistance along the problem. We need to solve this, but first we need to make it in a more simple way. We have this in a parallel, in a series, parallel, and series. To solve series in resistance, we need to apply the Ohm's rule for parallel circuits. There are 1 over the resistance. The total resistance is 1 over the resistance 1 plus 1 over the resistance 2 plus 1 over the resistance 3, and so on. This is for the first one, this one, the 3 of them, and this we solve this for the second one, the upper part, and we end up with this result: 2 resistance at the top and 2 at the bottom. We need to solve this as a series circuit, following the Ohm's law again, only this time applied for circuits in series. We have this value for the upper part, and we have this value for this part. We end up with a more simple circuit with 1 parallel and 1 series. We know now how to solve a parallel, so we solve it right here, and then we have a simple series, and then we solve them by adding them, and we end up with a single resistance of 8.07 ohms.
We must follow the next steps. First, find the equivalent resistance that is 8.07 ohms, and applying the Ohm's law, we can obtain the equivalent current of the whole circuit that is 1.486 amperes. Then we separate the equivalent resistance into more resistance. How to know if separated into series circuits or parallel circuits? Well, it is depending on the procedure used to obtain the equivalent resistance. We have 1 resistor and then we have 2 resistors. We have 1 resistor and then we have 2 resistors. And using the series and circuits and parallel circuits formulas, we know the current in the first resistor is the same current in the other 2 resistors because it's a series. And then we use Ohm's law and obtain that the voltage is these 2 values. Taking the voltage of the last step, we know that these 2 resistors are in parallel, and then we are going to find the current of each resistor. To find this, we are going to use again the Ohm's law, and we are still separating the circuit into more resistors. Now we are going to find the values of the voltage in the resistor 1, the resistor 2 and 3, the resistor 5 to 7, and the resistor 4, using again the same formulas of the Ohm law and the series circuits and parallel circuits formula.
3a. Explain the functioning of the coffee machine. 3 components are mainly characterized by the coffee machine. Number 1 is a reservoir that holds water. Number 2, a tube that carries the hot water into the deep area. And 3, a shower head that interacts with the hot water and the coffee grounds. Then it comes to the drip area and falls into the coffee mug.